So once again, I'm Helen, or Sunny Ladd from Duke University. This is a co-authored paper with Lucy Sorensen. Lucy, could you raise your hand? She's here to answer all questions, and we're very much a team on this. Lots of people have written about teacher turnover, and I'm hoping to convince you that we're adding in a constructive way to that literature. Lots of literature on high rates, documenting high rates of teacher turnover in schools across the country. Linda Darling-Hammond at the Learning Policy Institute has written about this. There are lots of reasons for this and lots of forms of teacher turnover. Now, a number of people have studied, and some people in this group have studied teacher turnover and expressed why we're unhappy with it. One concern of some is that it leads to teacher shortages. We're not looking at that issue today. To do that, we'd have to look at what's happening to the whole supply of teachers coming in through the teacher preparation programs, and we're not looking at that. Other people have emphasized the financial costs of teacher turnover. So those financial costs include costs at the school level of just spending time recruiting additional teachers. Some of those are at the county level or the whole district level, HR costs of various types. And then some people have looked at the adverse effects of teacher turnover on student achievement. Mentioned here papers by Rick Hanashek and company, and Ronfeld and Loeb and Wyckoff. They have a 2013 paper that's been highly cited using data on teacher turnover at the grade level, showing it adversely affects student achievement. So, but our focus is a little different, and it's consistent with some of these other articles. It's the extent to which teacher turnover leads to a disruption of the school environment. So when you have turnover, you have a possible reduction in the quality of the set of teachers in a school, and just the turnover itself, and then perhaps combined with the reduction in quality of a school, leads to a potential loss of coherence of the curriculum. So we're thinking about schools in which teachers interact with one another. So in our study, we examine how middle schools respond to teacher turnover among their 6th, 7th, and 8th grade math teachers and ELA teachers. We're using North Carolina data between the years 1998 and 2016. So the one question you might ask, well, why in the world are we focusing on middle school teachers? Well, our sense is that, and I'll be interested in the policymakers' response to this, that often the middle school teachers have to work together. So you have a set of math teachers at the middle school level, and students are taking different courses, and so they need to offer some sort of coherent curriculum for the students who are in those grades. And in some ways, the teachers may be interchangeable. Somebody who teaches 6th grade math could probably teach 8th grade math. So what that means is the departure of one teacher is likely to affect the other teachers in various ways, in ways we don't fully explore. Now, this middle school level differs from the elementary school level, where the typical situation is you have a single teacher in a whole classroom, and if one teacher leaves, that may mess up that classroom, but you don't have the loss of the coherence that we're talking about. And in the high school level, with different students taking a whole range of courses, it's unclear how one would think about the coherence of the curriculum. So we like the middle school setting. So our main question in this research is, what strategies do schools use to respond to the turnover of their teachers? And I'll talk more about this throughout. We're going to look at the net effect on the mix of teachers in the school of teacher turnover. So what might they do? Well, if you have high turnover of teachers, you might increase class size. So we'll look at that. They might hire less qualified teachers. They lose a lot of teachers, a lot of high turnover. They might hire less qualified teachers, or they might switch teachers across subjects or grade levels. So if you lose half of your math teachers, you may have to find some non-math teachers to teach your classes. So we've got some secondary questions as well. Are there differential responses in hard to staff schools compared to easier to staff schools? Are there differential responses by the state of the economy or the policy context? So let me just tell you a little bit about the North Carolina education context. You've heard me or others talk about this in the past. There have been dramatic reductions in education spending during the recession, starting in 2009 and going throughout the recession. And then in 2010 in North Carolina, the legislature changed dramatically and became very Republican and very conservative. So there was a continued decline even after the recession ended in teacher salaries and also in spending. In 2012 or 13, there was the removal of teacher tenure, advanced degree initiatives. There was the ending of a very popular program, a small program called the Teaching Fellows Program. So one result of all of these changes has been low morale among teachers, and we've got a little data here. At one point, 97% of the teachers thought that the recent legislative changes had a negative effect on teacher morale. A number said they were less likely to continue teaching or staying in the school as a teacher or administrator. So we're going to use administrative data from North Carolina. It comes from the Education Research Data Center, which is housed at Duke. We've got teacher, classroom, and school matched records. We're using the period 1996 to well, the data we start with are 1996 to 2016, but all of our models are 1998 to 2016, and that's because, and I'll mention this in a minute, we're going to use 3-year averages of our turnover rate, so we have to use the first 2 years to calculate that turnover rate. We're focusing on middle school classrooms in math and ELA. We've collapsed this school level, collapsed everything to the school level year data. Notice we're not collapsing to the grade level. So everything will be at the school level, 6th, 7th, and 8th grade, and we have data by year. We've got about 16,000 observations, but we have them by subject. So 8,000 of those observations over our period are for math teachers, and about 8,000 are for English language ELA teachers. Now we have made a few sample exclusions throughout we've taken out really small schools or schools in which there are only 2 or 3 teachers and whatever. So I'm not going to talk about those now, but they're in the paper. So let's look at our key measures. First measure, the one we're most interested in, is teacher turnover. And again, this is by school, subject, and year. It's not specifically by grade, but we had data. We know the teachers at each grade, and we've lumped them together. We can define a 1-year turnover measure. That's the leavers, the teachers who leave in year T-1 last year, as a fraction of the teachers of that type in the school in T-1. So it's the previous year, and that's what we want, because we want the response in the current year to the turnover in the previous year. Now, in fact, in most of our models, we take an average 3-year turnover rate, so that it's not just a 1-year blip of some sort, but we're looking at an average over 3 years. And that's our preferred measure, but we also do a number of robustness checks and look at 1 year, the effects of 1-year turnover rates as well. Now, our outcome variables are at the school, subject, and year level, and we're interested in outcomes such as the percent of teachers in year T with 3 or fewer years of experience, with lateral entry or provisional license, or who are teaching out of subject, and we can determine in our data whether teachers are teaching non-math or ELA subjects. We've got data on average teacher licensing exam scores, so the lower those scores, the lower the qualifications of the teacher, and another outcome measure is average class size. So just to give you a sense, this is the average 3-year school turnover rate, and we've calculated this both for math and ELA teachers, and this combines them, but we've also done it separately. Notice the axis over there starts at 22%, and then goes up to a peak of 25% at the beginning of the recession. So that initial period, there was a period of rapid student growth, or growing, and so we had high teacher turnover. Then look what happens during the recession. During the recession, that 25% rate, or whatever it is, drops way down to 22%. These turnover rates, by the way, are high compared to turnover rates in other states or other grades. And then after 2012, the turnover rate heads up again. So we clearly have some changes over time in the turnover rate, and we'll come back to see if schools respond differentially in the 3 main time periods: the one prior to the recession, during the recession, and then after the recession. So here's our empirical strategy. We're going to estimate some regression models. The basic model is just an outcome, one of those outcomes, percent of teachers, for example, who are novice, as a function of the average turnover. And we're going to use the average 3-year for the results I'm going to show you, and a whole set of control variables where the outcomes are at the school level, once again, by year and subject. So in our equations, we've got math outcomes, or outcomes for math teachers and for ELA teachers. And now we've got 2 models. Most of the time I'm just going to focus on model 1, but initially I'll focus on both. The controls in model 1 are a whole vector of time-varying school covariates. So we're looking at including the student composition of the school by gender, race, and economic disadvantage. We've got school fixed effects and year fixed effects. Those school fixed effects are important because we're trying to push in the direction of having causal models. How does turnover cause, or what's the effect of that on the mix of teachers in the following year? So by including school fixed effects, given we've got panel data, we're controlling for a lot of unobservable characteristics at the school level. Now, as we all know, fixed effects just control for the time invariant characteristics of a school, and that's what leads us to model 2. You might say, well, maybe there were some other jolts to the school that changed how they responded. So model 2 is just model 1 with all the controls, including the school fixed effects, but also school by year fixed effects. Now notice once we add school by year fixed effects, the only variation we've got remaining is within a year in a school, the difference between the loss of math teachers and the loss of English teachers. So we lose some things, but we gain the ability to say, look, the effects aren't just caused by some outside force that affects the schools. So I'm not going to spend a lot of time. My next graph will interpret some of these coefficients, but I want you to see what we've got. The columns labeled 1 and 2 way on the left is one of our outcome measures, the proportion of teachers 0 to 3 years of experience. And then as we go across, we've got proportion of teachers lateral or provisional license, average teacher licensure, and well, you can see them coming across to average class size over here. Now, each of these are separate. Each column is a separate regression model. I've included information at the bottom, like the sample size is over 16,000. You see R squared, and then you can see whether we've got student fixed effects or school fixed effects, sorry, or school by year fixed effects, which is the case in the second one. Let's start with proportion of teachers 0 to 3 years of experience. So what we're saying here is the turnover rate goes up. How do teachers respond? How do schools respond? The positive coefficients, ones in red in those first 2 columns, say they increase the proportion of novice teachers in response. And in the next slide, I'll interpret those numbers for you, but just pay attention to the signs now. And by the way, if you compare the results in column 1 and 2, you'll see model 1 and model 2 generate essentially the same results. Proportion of teachers who are lateral or provisional entry, positive coefficients there. So schools are responding to teacher turnover by hiring, by increasing the proportion of schools who are lateral or provisional licensed teachers. Let me just emphasize again, it's not that they're just hiring those. These are the net effects. You have turnover, and then what happens to the mix of teachers in the school. So it's the net effect of teachers leaving and teachers coming in. The next two columns are average teacher licensure score in Model 1. Looks like there's a maybe statistically significant negative coefficient, and the Model 2, it's not as significant. So the effects aren't quite as strong, but same magnitude. And then the proportion of teachers teaching out of subject, the only statistically significant one is in Model 2. Now notice for average class size, we don't have any statistically significant coefficients. That doesn't surprise us at all and may reflect the North Carolina situation. North Carolina has statewide regulations on class size and their maximum class size. So schools can't easily respond to a loss of teachers by increasing class sizes, and that's consistent with what we find. So just to summarize these, an increase in average turnover from a 25% turnover to 35% would increase the proportion of novice teachers. This is the net effect of teachers who leave and teachers who come in by 3.6 percentage points. And that's from an average of about 21%. So that's about a 15% increase. Increased proportion of lateral entry or provisional teachers by 1.3% points, and that's about a 10% increase. And it may well, I mean, the results are less statistically significant, decrease average licensure exam scores of the set of teachers in the school, and it maybe increases the proportion of teachers teaching out of subject by about 0.8 percentage points. And then, as I mentioned, there's no impact on class size. If we look quickly at the differential responses by characteristics of the schools, we get, for the low-performing schools, those with high gains in achievement, they're likely to respond over time by hiring more lateral entry provisional teachers than other schools. What I failed to include in this graph or slide, but shouldn't surprise you, high poverty schools differ statistically. We estimate these with interaction terms in our model. High poverty schools differ from low poverty schools by having higher, by ending up with more lateral provisional entry teachers. We get no differential response across urban and rural schools, and no differential response across different geographic distances to the nearest teacher education program. Our hypothesis there was, well, if you have teacher education programs nearby and you lose a lot of your teachers in 1 year, it might be easier to hire more, but we didn't find any evidence of that. Differential responses over time, I've already mentioned the 3 time periods, the pre-recession period, the recession, post-recession. And once again, we have interaction terms in our model. And the main finding is during the recession, there was a much smaller effect on the shares of lateral entry or provisional teachers or reliance on out-of-subject teachers. That's not surprising. During the recession, it was easier for schools to replace teachers that left with teachers with standard qualifications. So let me quickly, this is my next to last slide, talk about contributions to the literature. We think this analysis represents, well, it does represent the net effect. So I want to highlight that word net effect of 2 types of flows. So it's not a separate analysis of the teachers who leave and the teachers who come in. Focuses on effects of turnover in the school environment. Key findings I've already talked about. And our argument is that School capacity is reduced by the increased proportions of low-quality teachers, by the influx of new and inexperienced teachers relative to the ones who are there, who are likely to be disruptive and to interfere with the development of a coherent curriculum. And the compositional change is likely to increase turnover in the future as well because of the greater proclivity of the identified groups to leave the school. I have a slide on implications for policy, but I'm told my time is out, so I'll let Carrie talk about that.